Hi everyone, this is Mr. Bowman, and in this video we're going to talk about using integration to measure net accumulation or the change in a quantity. So we're going to start with this problem. This is a graphing calculator problem, and let's see what it tells us. There is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by f of t is equal to, notice that that is a rate, in cubic feet per hour, where t is measured in hours since midnight. Janet starts removing snow at 6 a.m., t is equal to 6. The rate g of t, so another rate, in cubic feet per hour, again the same units, at which Janet removes snow from the driveway at time t hours after midnight is modeled by this piecewise function. So basically what this is telling us is that from 0 to 6 a.m. she is not removing snow at all. From 6 to 7 a.m. she is removing snow at a rate of 125 cubic feet per hour. And from 7 to 9 a.m. she is removing snow at a rate of 108 cubic feet per hour. A asks us how many cubic feet of snow have accumulated on the driveway by 6 a.m. So essentially, since she hasn't started shoveling snow at that point, what we're going to do is we're going to integrate from time A to time B the rate function at which snow is falling, f of t dt, and we're going to get f of b minus f of a, basically the fundamental theorem here. And what we want to do is we want to put times of 0 and 6 a.m. in. So the integral from 0 to 6 a.m. of f of t dt is going to be the amount of snow at 6 a.m. minus the amount of snow at midnight. But we know the amount of snow at midnight is 0. So essentially, the amount of snow at 6 a.m. is that integral, which you can do in your calculator. Make sure you are in radian mode. And if you evaluate that in your calculator, you will get the following. You will get that integral is 142 0.275 feet cubed. So that's the answer for part A. Let's go over the scoring rubric and take a look at what they would give points for. In the scoring rubric, they are looking to see the integral from 0 to 6 of f of t dt, or 142.274 or 275 cubic feet. And so we would get 2 points for that portion. In part B, they are asking us to find the rate of change of the volume of snow on the driveway at 8 a.m. Okay, so this is where you really have to pay attention to what they're asking. They're asking for the rate of change of snow at 8 a.m. So we've got two rates of change. We've got the rate at which snow is accumulating, f of t, and we've got the rate at which snow is being removed, g of t. And at 8 a.m., we would use this portion of the piecewise function for g of t. So b is simply f of 8 a.m., or f at 8, minus g at 8. And again, you can go to your calculator and find an answer there, and that answer is going to be negative 59.583, and this is in cubic feet per hour. So let's take a look at the scoring rubric and see how they would score that. In the scoring rubric, f of 8 minus g of 8, and they would only give 1 point for that. So far we only have 3 points accounted for out of the 9, which means the remaining 2 parts are going to account for the 2/3 or 6 points out of the total of 9. Part C says let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h as a piecewise defined function with domain 0 to 9. Okay, so let's think about this. H is the total amount of snow in cubic feet Janet has removed from the driveway at time t hours after midnight. So we're going to have to integrate g of t to get the answer to that. So h of t is equal to the integral from 0 to t of g of t dt. And as a result, we've got three parts to that. We've got, she removed 0 snow from 0 to 6 a.m. And let's go up and make sure that we record that correctly. So 0 to 6 a.m. And from 6 a.m. to 7 a.m., she was removing snow at a rate of 125 cubic feet per hour. So we have to integrate the function from 6 to t of 125 dt. And t could be any number from 6 to 7 a.m. So if we integrate that, we've got 125 t, and we're going to go from 6 to t. So that's going to be 125 times t minus 125 times 6, or 125 times t minus 6. And you could essentially figure that out with calculus. Basically what you're saying is plug any number greater than 6, less than 7 in there, and multiply it by 125, and that's how much snow she has removed. So 125 times t minus 6. All right. For the next part of this piecewise function, from 7 to 9 a.m., this gets a little bit more complicated, but you just have to think about it carefully. So h of t is going to be equal to the integral from 7 to t of g of t dt plus the amount of snow that was present at time 7, which we would call h of 7. Well, if you plug 7 into this piecewise function in the middle where t is from 6 to 7, you're basically going to have 1 times 125. So h of 7, the amount of snow on the driveway at 7 a.m., or that has been removed from the driveway, at 7 a.m. is 125 cubic feet. So h of t from 7 to 9 a.m. is going to be the integral from 7 to t of 108 dt, because it's being removed at 108 cubic feet per hour, plus 125. And if you do the calculus on this, you get 108t from 7 to t plus 125, and that turns out to be 108 times t minus 7 plus 125. Again, you could figure this out with calculus, but the calculus is what they're looking for. So 108 times t minus 7 plus 125. So that's our piecewise function. Let's take a look and see how they would score this. All right, so essentially they did what we did using the fundamental theorem and integrating the rates, and you get 1 point for each part of the piecewise function, and you can see this is the piecewise function that you get. If you'd like to take a look at their work for this, just pause the video and take a look above what I circled in red. Okay, so that is all but 3 of the points accounted for in this problem. And the last part says, how many cubic feet of snow are on the driveway at 9 a.m.? Well, so what we have to do is we have to take h of 9, the function that we just found, and that's how much has been removed at 9 a.m. And we're going to subtract that from the integral from 0 to 9 of f of t dt. So for part D, our answer to this is the integral from 0 to 9 of f of t dt. This gives us the total amount of snow that has accumulated on the driveway minus h of 9. And we can go ahead and evaluate that. And from our calculator, we find this to be 367.335. And h of 9 is going to be 108 times 9 minus 7, so 2 hours at 108 cubic feet per hour, plus 1 hour at 125 cubic feet per hour. And if you simplify this, you get 26.335 cubic feet. Let's see how they would score that. All right, amount of snow is the integral from 0 to 9 f of t dt minus h of 9. And really, you don't have to show all the work that I did, but the integral, including h of 9, and the final answer. And there's your 3 points.